Hi everyone, morning. You weren't shading about that, it doesn't work. Okay, my name is Asaf. I lead the security product management team in Qualcomm as part of our technology organization. I'm here to share with you some thoughts and views from a mobile SoC manufacturer perspective about trust and attestation in a modern SoC, system on chip. So first, I'm happy to announce that as of, I think, last week, we are members of the C2PA. In terms of what drove us to kind of take that decision, I mean, looking at generative AI, the state of it right now and the pace of development, it was very obvious for us that along with the great kind of usage, the ways that it is put to use already, we see already abuse coming with that technology. It is guaranteed that it will continue, and we felt that we need, trust, authenticity, provenance attestation. These are critical components for making that technology more usable. So we are committed to that, and we took that decision to join the coalition. Okay, so before I kind of talk a bit about the work that is being done in the context of C2PA in our SoCs, I wanted first to touch upon generative AI and the current capabilities that are out there. So when you look at, for example, our latest premium mobile SoC, Snapdragon 8 Gen 3 that we recently launched, it comes with what we believe is kind of pretty impressive set of Gen AI capabilities. I'll show you a couple of videos of demonstrations that we had in our launch event. And there are good reasons to run Gen AI on the edge device as opposed to the cloud. If you look at some of the things that it enables from performance perspective, it helps with performance. The ability it simplifies the training, the personalization of the model on the device itself. You have all the information available there without leaving. Of course, it helps with privacy. No need to send anything to the cloud in order to kind of generate the tokens. It also drives down cost. If you compare the cost of token generation on a device compared to the cloud, it is simply cheaper. And we see kind of it resonates, those reasons seem to resonate well with the ecosystem. We are getting good feedback for that direction of hosting those models on the device itself. I mean, it mainly starts with the OEMs, the mobile OEMs first, but there's definitely appetite to go beyond that and to enable a broad ecosystem of Gen AI models to be executed on the edge device. That by itself is an interesting challenge. How do you protect a model owned by a third party that doesn't necessarily trust the OEM, but that's a different story. Okay, so with that, as promised, I wanted to share again, before I go into what we are doing in this context, I wanted to share some of the capabilities in terms of Gen AI on an edge device, a mobile device today. The first use case that I'm showing here is photo expansion, which is the user loads an image from the gallery, and then the view is zooming out, and a Gen AI actually kind of fill in the blanks. So hopefully that will work. Oh, yeah. So hopefully that will be marked with regions of interest that you mentioned before. The other demo that we have here, or the video of a demo, and again, all that was demonstrated in 2 months ago in our kind of launch event for our next premium flagship. This is Stable Diffusion. So earlier this year, when we introduced Stable Diffusion on an edge device for the first time in Mobile World Congress, it was pretty impressive achievement given the size of the model. But when you look at the performance, the latency for generation was about 14 seconds. And after the initial kind of excitement, it became clear that this is not really acceptable. Now we are demonstrating something very different. I like the music on that one. Okay. So, I mean, while we obviously will continue to offer what we think is best-in-class Gen AI capabilities on our Snapdragon SoCs, I mean, it was very clear to us that we need to address the abuse potential that comes along with it, and we need to offer an implementation. So we took that decision to have a C2PA compliant implementation in the device, but we wanted to set the bar higher than kind of your typical high-level OS assurance level. And this is where kind of the discussion starts to zoom in into the intricacies of a mobile kind of system on chip. So we wanted to enable trust also in the presence of a compromised high-level OS. And with that, and so we decided to kind of host the implementation, run the implementation in an environment that has a higher assurance level, which means smaller TCB, trusted code base, and simply put, smaller attack surface. So we took this is known as a TE, a trusted execution environment, and de facto we decided to have a TE level or hardware level, if you will, for that C2PA implementation, and that has all kind of implications, which I'll get to in a second. But maybe before we kind of go into the meaning of that TE level of assurance, I just wanted to emphasize the fact that, again, a modern mobile SoC, not just mobile, but that class of system on chip, that has a lot of, under the hood, there are a lot of different processing environments. In each such processing environment, all integrated in one not very big piece of silicon, each such environment has its own hardware processing elements, firmware, operating system, application-related workloads. So a lot of things are going on in parallel in all these environments. And given that we want neither synthetic content from being presented as real, nor real content from being presented as, you know, the perfect, or not perfect, but AI generated, so we need to consider both the kind of the processing pipeline of both the real world sensed media as well as the generated, the AI kind of environments. Under the hood, there are quite a lot of subsystems that are involved, and each such subsystem typically has multiple execution environments within that subsystem. And they differ in again, the kind of the attack surface that gets exposed. So basically trading off functionality richness with security within each and every environment that we have there. And if you add to that, I mean, specifically in the context of C2PA, in the context of assertions, they might be coming from, they might originate, or they originate in very different environments within this SoC, and they need to go into the same claim, into the same credentials. So again, just calling out the complexity of the challenge. Okay. So I want to dive into some of these challenges specifically, because when we introduce that TE level, de facto, we are introducing the sense of multiple levels of trust, because not all implementations out there will be TE-based necessarily. And that TE or hardware level of trust, obviously the goal is to convey a higher sense of trust, but that needs to be handled with care, because we definitely don't want to create a false sense of trust. So just calling out some of the challenges that we see there. First is, of course, how do we indicate those different levels of trust? Again, when you consider the multiple environments over which the claim is formed, can we really achieve a kind of a monolithic level of trust for all these environments for a certain claim for content? If you consider different assertions like time, location, the thumbnail of the image that gets signed, again, they are all coming from different environments within the subsystem. And so the key that signs the claim very well may be well protected. It can be a TE key handled within a proper TE environment, but if the content that is given for that signature is randomly gathered somewhat, then of course it has perhaps limited value, or at least that needs to be indicated one way or another. Another kind of challenge that we see is how do we provide assurance that an implementation really achieves the level that it claims. So, I mean, for us, maybe now that we are C2PA members, we will get to know more about kind of the thinking and the directions within that ecosystem. Generally speaking, for us, that means that there needs to be a kind of assurance program and a certifier, a validation and evaluation program with a certifier for that. Or else we see, I mean, just from other spaces, making claims is pretty easy. Having a reputable third party attesting to that is a different story altogether. And then, of course, again, once that extra level of complexity, perhaps, by the fact that we are having potential multiple levels of trust, how do we translate that into something meaningful for the user, right? I mean, your average consumer will not know what is a TE or will not care about that. But how do you translate that into something truly consumable and understandable for a consumer? Okay, so I want to, I'm using here a picture that is kind of the typical security stack and components that we bake into a mobile SoC and the different execution environments under the hood that run that stack. But this is mainly as background. I want to double click on some of the challenges that I just mentioned, again, in the context of the potential to have more than one level of trust for kind of the original creation of the image. So one aspect relates to keys, the signing key. So again, we are talking about a TE level of security, so the key that is signing the claim at the end of the process. How do we assure that these keys are only provisioned for devices that are actually equipped with the right capabilities? How do we assure that the rotation process is done correctly? And that is on top of the usual kind of aspects of how do we assure that the keys are handled at rest, in runtime, at the kind of right assurance level. And this is where my earlier comment about certification, of course, and having things evaluated come into play. Another kind of example is, again, in the context of these multiple processing environments within the device or within the SoC. If you think about the pipeline for capturing an image, it goes through the camera subsystem, it goes through the application processor, potentially it goes through the neural processing unit, so it travels a lot. And then can we really have the same, like all these environments have different security foundation potentially. Do they all really offer isolation at a TE level? And so if you look today at what is called typically the 3A set of algorithms, the auto expose, auto focus, auto white balance, and other autos as well, all of that is done in typically it gets done in the OEM camera framework, which runs in the high-level OS, not in any TE. So this is just one example of such complexity in the sense that can we kind of classify the resulting claim at the same assurance level when it combines aspects coming from multiple domains. Same goes for the generated content kind of environment. So The AI framework, I mean, that goes to the GPU, application processor, any AI accelerator that exists in the SoC. Same challenges. How do we assure that they all kind of provide the same level of isolation and assurance? In general, I guess what I'm trying to say is that once that additional level of assurance is introduced, we want to make sure that assertions can be mapped accurately to kind of the trust level that can be, that is relevant for them. We want to avoid ambiguity when it comes to the interpretation of individual assertions. And probably there's more than one way to go about it, but again, just calling out some of the challenges. So with that, I've mentioned kind of some of the motivations that drove us to decide on doing something in this space, and some of the challenges we identify. I want to call out the fact that we are working with CuPIC on embedding such C2PA implementation at a higher assurance execution environment. So it's a C2PA trusted application running in a Qualcomm TEE. Through this process, I think it's true for both CuPIC and Qualcomm. We kind of learn about these challenges and different options to go about it. Hopefully that kind of gathered information will be useful for the community. And this is my last slide. It's still 1:04. And I just wanted to acknowledge that, I mean, while we are focusing now mainly on images, we acknowledge the clear need to provide similar level of trust for any other manner the consumer device can sense the real world. And so we kind of identified that finish line or goal, but obviously that will be a journey and it will take some time to get there, but the need is, and what we see out there in terms of kind of threats, that is really clear. With that, I'd like to thank you.